So let's go back and take a closer look at some of the things that we more briefly mentioned earlier videos. And let's look more in depth at the sensation and motor parts of the brain. And recall that we're looking at the anatomy where this is the central sulcus that divides the frontal lobe, right, that is rostral, to the caudal parietal lobe. And in the parietal lobe, we have this band of tissue called the postcentral gyrus, the central sulcus, and then the precentral gyrus of the frontal lobe. So these are the areas where we're going to concentrate, and because we're talking about sensation, we're going to concentrate on this purple band, this purple gyrus right here in this particular video. So this is called the primary sensory cortex. This is where sensory inputs, if you recall back when we were talking about ascending tracts, delivering sensory information, the first order neuron took information from the surface of the body and delivered it into the to the spinal cord. And then the second order neuron carried that information up the spinal cord to the thalamus, and then the tertiary or third order neuron carried that information from the thalamus to the particular region of the cortex that deals with that. And here we are in that particular region of the cortex that deals with that sensory information from the body wall. Now we're going to take in that information, but then to process it, we're going to use association areas out here in the parietal lobe to begin associating all that sensory information with other inputs. All right, so the sensory association areas, we have the premotor cortex, which is found in the frontal lobe. So we're going to see it's going to be a part of this because we have to respond to the sensations perhaps in some way, so that would bring in the premotor cortex. And then you have the primary somatic sensory association area in the parietal lobe. Finally, we have the visual association area that's going to be found in the occipital lobe. And I said finally, but I mean also we have the auditory association area that's associated with hearing information coming in through your temporal lobes. So these are all the association areas for sensory inputs and in the brain, the major ones, and also including throwing in there the premotor cortex. So the cerebrum also employs integrative areas that are even higher level than these association areas. So all the association areas then will form and send commands or information to this integrative area. These are found in the brain areas as well, in the different lobes, and are going to associate information from the association areas. They direct incredibly complex activities. Now we have to consider, here's where we're going to start separating, and we'll continue this as we move along into chapter 16, the special senses from the general senses. The general senses, again, are those that report from the body wall, from your joints, from your muscles, pain, temperature, touch, and so forth from the body wall. But special senses are pretty much limited to those found in the head. Eyes, right, for vision, hearing, taste, and smell. Right? So for the special senses, visual information is processed in the occipital lobe. That's the sensory location for it. And the area called the visual association area, which is going to try to make initial sense out of what you're seeing, is found in the rest of the occipital lobe. Now, the visual information is pressed forward to the lower regions of the temporal lobe to deal with facial recognition and object recognition. Hearing comes in the hearing cortex, of course, is in the temporal lobe. The association area for the hearing information is in the temporal lobe as well. And here's where we're going to associate with, particular types of music, sounds, patterns, and so forth. Equilibrium is one we haven't really considered up to this point, but equilibrium is absolutely essential, and it comes from devices or anatomical locations located in the inner ear that we'll talk about in chapter 16. And this is found really close to the central, the most lower end, inferior end position of this central sulcus. And equilibrium has to do with where we are in space, our orientation. So we're going to utilize that. It, of course, is a major player in the seat of consciousness, because for us to be conscious, we have to understand where we are in the world. Otherwise, we are disoriented. Taste and smell are the other special senses we'll talk about. And taste is processed in the parietal lobe, and smell mostly in the temporal lobe. And we'll talk about how these two largely interrelate in chapter 16 again. Now, the general senses, as we already talked about, include the entire body wall and incorporate fairly simple receptors that are going to be detecting pain, temperature, cold, heat, in terms of, and also in terms of movement and position. The ascending tracts bring that information in and deliver it to the somatosensory cortex in the parietal lobe. This cortex is also known as the post-central gyrus. And as it turns out, we're going to see that this gyrus, from the most caudal position to the roof, is going to be able to be mapped out according to its position in the body. So there's the two different major gyri and the central sulcus. And we're going to look mostly at the post-central gyrus right now, and we'll refer to the precentral in the next video. And so the general senses, we've already talked about how they're processed in the somatosensory cortex. So in the somatosensory association area, we're going to make sense out of those inputs. We're going to become aware of them and respond to them appropriately. Remember, because of decussation, most sensations will come in contralateral from where they begin at. Now, as I told you, there's going to be a body position map on this gyrus that will correspond to how much sensory inputs come from a particular area of the body, and this is going to be called the homunculus. Okay, this is a sensory map, if you will, of the contralateral side of the body, and it employs the concepts called somatotopy. And somatotopy means there is a correlation between a region on the body and a particular location in the brain. Let's look at that. So you see here we've got the different locations in the brain, in the body, demonstrated here, and we're going to show you the sensory homunculus, and there you go. And so you see that along this purple band, along the somatosensory cortex, we have a map of the body. This is incredible, right? And so we can put a little stimulus, and we will be able to register a sensory signal in that neuron right there in that position, in that gyrus, right in there. And so you'll notice also that the face gets an overwhelmingly large amount of real estate. We have the visceral organs that get a little bit. The hand gets a lot, but nothing like the face. And the rest of the body gets pretty much little. And then you'll notice down here, we're inside the longitudinal fissure right here. This is where the genitalia will, for sensitivity for genitalia is covered. Now I want to point out briefly that you'll notice how it's closely related to the toes. And so you know that neurons are coming into this area of the gyrus and also to the toes, and so sometimes you might get overlap neurons between the toes and the genitalia, and that is why that foot fetishes are fairly common among humans, is that stroking of the feet and toes will also make you feel like your genitalia are being stroked as well. All right, so here we have an upside down sensory map from the longitudinal fissure all the way through into the region, and this is where the temporal lobe will begin down here, but all the way pretty much to the base end of the post-central gyrus.